Toefl reading section, thermoregulation. P1. Mammals and birds generally maintain body temperature within a narrow range, 36-38 degrees Celsius for most mammals and 39-42 degrees Celsius for most birds. That is usually considerably warmer than the environment because heat always flows from a warm object to cooler surroundings. Birds and mammals must counteract a constant heat loss. This maintenance of warm body temperature depends on several key adaptations. The most basic mechanism is the high metabolic rate of endothermy itself. Endotherms can produce large amounts of metabolic heat that replace the flow of heat to the environment, and they can vary heat production to match changing rates of heat loss. Heat production is increased by such muscle activity as moving or shivering. In some mammals, certain hormones can cause mitochondria to increase their metabolic activity and produce heat instead of ATP. This non-shivering thermogenesis (NST) takes place throughout the body, but some mammals also have a tissue called brown fat in the neck and between the shoulders that is specialized for rapid heat production through shivering and NST. Mammals and birds in cold environments can increase their metabolic heat production by as much as 5 to 10 times above the minimal levels that occur in warm conditions. P2. Another major thermoregulatory adaptation that evolved in mammals and birds is insulation, hair, feathers, and fat layers, which reduces the flow of heat and lowers the energy cost of keeping warm. Most land mammals and birds react to cold by raising their fur or feathers, thereby trapping a thicker layer of air. Humans rely more on a layer of fat just beneath the skin as insulation. Goosebumps are a vestige of hair rising left over from our furry ancestors. Vasodilation and vasoconstriction also regulate heat exchange, and many contribute to regional temperature differences within the animal. For example, heat loss from a human is reduced when arms and legs cool to several degrees below the temperature of the body core, where most vital organs are located. P3. Hair loses most of its insulating power when wet. Marine mammals such as whales and seals have a very thick layer of insulation fat called blubber just under the skin. Marine mammals swim in water colder than their body core temperature, and many species spend at least part of the year in nearly freezing polar seas. The loss of heat to water occurs 50 to 100 times more rapidly than heat loss to air, and the skin temperature of a marine mammal is close to water temperature. Even so, the blubber insulation is so effective that marine mammals maintain body core temperatures of about 36-38 degrees Celsius with metabolic rates about the same as those of land mammals of similar size. The flippers or tail of a whale or seal lack insulating blubber, but countercurrent heat exchangers greatly reduce heat loss in these extremities, as they do in the legs of many birds. P4. Through metabolic heat production, insulation, and vascular adjustments, birds and mammals are capable of astonishing feats of thermoregulation. For example, small birds called chickadees, which weigh only 20 grams, can remain active and hold body temperature nearly constant at 40 degrees Celsius in environmental temperatures as low as -40 degrees Celsius, as long as they have enough food to supply the large amount of energy necessary for heat production. P5. Many mammals and birds live in places where thermoregulation requires cooling off as well as warming. For example, when a marine mammal moves into warm seas, as many whales do when they produce, excess metabolic heat is removed by vasodilation of numerous blood vessels in the outer layer of the skin. In hot climates, or when vigorous exercise adds large amounts of metabolic heat to the body, many terrestrial mammals and birds may allow body temperature to rise by several degrees, which enhances heat loss by increasing the temperature gradient between the body and a warm environment. P6. Evaporative cooling often plays a key role in dissipating the body heat. If environmental temperature is above body temperature, animals gain heat from the environment as well as from metabolism, and evaporation is the only way to keep body temperature from rising rapidly. Panting is important in birds and many mammals. Some birds have a punching richly supplied with blood vessels in the floor of the mouth. Fluttering the pouch increases evaporative. Pigeons can use evaporative cooling to keep body temperature close to 40 degrees Celsius in air temperatures as high as 60 degrees Celsius, as long as they have sufficient water. Many terrestrial mammals have sweat glands controlled by the nervous system. Other mechanisms that promote evaporative cooling include spreading salvia on body surfaces, an adaptation of some kangaroos and rodents for combating severe heat stress. Some bats use both salvia and urine to enhance evaporative cooling. Glossary ATP, energy that derives certain reactions in cells. Mitochondria, a membrane of ATP. Question 1. According to paragraph 1, the most fundamental adaptation to maintain body temperature is A. The heat generated by the metabolism. B. A shivering reflex in the muscles. C. Migration to a warmer environment. D. Higher caloric intake to match heat loss. Answer. The most basic mechanism for maintenance of warm body temperature is the high metabolic rate. Choices B, C, and D are always to maintain body temperature, but they are not the most fundamental adaptation. Question 2. Based on information in paragraph 1, which of the following best explains the term thermogenesis? A. Heat loss that must be reserved. B. The adaptation of brown fat tissue in the neck. C. The maintenance of healthy environmental conditions. D. Conditions that affect the metabolism. Answer. In some mammals, certain hormones can cause mitochondria to increase their metabolic activity and produce heat instead of ATP. This non-shivering thermogenesis, NST. Choice A is not correct because thermogenesis is the activity that generates heat, not a heat loss. Choice B is not correct because brown fat is one example of a more generalized process. Choice C is not correct because thermogenesis is a response to the environment to maintain the health of the animal, not a process that maintains the environment. Question 3. Which of the sentences below best expresses the information in the highlighted statement in the passage? The other choices change the meaning or leave out important information. A. An increase in heat production causes muscle activity such as moving or shivering. B. Muscle activity like moving and shivering will increase heat production. C. Moving and shivering are muscle activities that increase with heat. D. When heat increases, the production of muscle activity also increases. A passive grammatical structure in the passage is paraphrased by an active grammatical structure in the answer choice. Question 4. The word minimal in the passage is closest in meaning to A. Most recent. B. Most active. C. Newest. D. Smallest. Answer. In this passage, smallest is a synonym for minimal. Question 5. In paragraph 2, the author explains the concept of vasodilation and vasoconstriction by A. Describing the evolution in our ancestors. B. Giving an example of heat loss in the extremities. C. Comparing the process in humans and animals. D. Identifying various types of insulation. Answer. For example, heat loss from a human is reduced when arms and legs cool. Choice A is not correct because goosebumps, not heat loss in the extremities, is a vestige of our evolution. Choice C is not correct because no direct comparisons of these processes are made in the paragraph. Choice D is not correct because the types of insulation are mentioned before the concept of vasodilation and vasoconstriction are introduced. Question 6. The word regulate in the passage is closest in meaning to A. Protect. B. Create. C. Reduce. D. Control. Answer. In this passage, control is a synonym for regulate. Context comes from the reference to temperature differences at the end of the same sentences. Question 7. According to paragraph 3, why do many marine animals require a layer of blubber? A. Because marine animals have lost their air during evolution. B. Because heat is lost in water much faster than it is in air. C. Because dry hair does not insulate marine animals. D. Because they are so large that they require more insulation. Answer. The loss of heat to water occurs 50 to 100 times more rapidly than heat loss to air. Choice A is not correct because hair loses insulating power when wet, but the evolution of marine animals is not mentioned. Choice C is not correct because dry hair insulates better than wet hair. Choice D is not correct because there are land animals that are of similar size. Question 8. The word those in the passage refers to A. Marine animals. B. Core temperatures. C. Land mammals. D. Metabolic rates. Answer. Marine mammals maintain body core temperatures of about 36-38 degrees Celsius, with metabolic rates about the same as those metabolic rates of land mammals of similar size. Question 9. Why does the author mention chickadees in paragraph 4? A. To discuss an animal that regulates heat very well. B. To demonstrate why chickadees have to eat so much. C. To mention an exception to the rules of thermoregulation. D. To give a reason for heat production in small animals. Answer. Capable of astonishing feats of thermoregulation. For example, small birds birds called chickadees hold body temperature nearly constant. Choice B is not correct because the food supply supports thermoregulation, which is the main point of the example. Choice C is not correct because chickadees are capable of astonishing feats of thermoregulation. Choice D is not correct because the reason for heat production in animals is explained before the example of the chickadee. Question 10. In paragraph 6, the author states that evaporative cooling is often accomplished by all of the following methods, except A. By spreading salvia over the area, B. By urinating on the body, C. By panting or fluttering a pouch, D. By immersing themselves in water. Answer. Choice A is mentioned in paragraph 6, sentence 7. Choice B is mentioned in paragraph 6, sentence 8. Choice C is mentioned in paragraph 6, sentence 3 and 4. Question 11. The word enhance in the passage is closest in meaning to A. Simplify, B. Improve, C. Replace, D. Interrupt. Answer. In this passage, improve is a synonym for enhance. Context comes from the reference to promote in the previous sentence. Question 12. Look at the 4 squares that show where the following sentence could be inserted in the passage. The insulating power of a layer of fur or feathers mainly depends on how much still air the layer traps. Where could the sentence best be added? Click on a square to insert a sentence in the passage. Answer. Reference is a transitional device that connects the insert sentence with the previous sentence. Question 13. Directions. An introduction for a short summary of the passage appears below. Complete the summary by selecting the 3 answer choices that mention the most important points in the passage. Some sentences do not belong in the summary because they express ideas that are not included in the passage or not minor points from the passage. This question is worth 2 points. Thermoregulation is the process by which animals control body temperatures within healthy limits. Answer choices. A. Although hair can be a very efficient insulation when it is dry and it can be raised, hair becomes ineffective when it is submerged in cold water. B. Some animals with few adaptations for thermoregulation migrate to moderate climates to avoid the extreme weather in the polar regions and the tropics. C. Mammals and birds use insulation to mitigate heat loss, including hair and feathers that can be raised to trap air as well as fat or blubber under the skin. D. Some birds have a special patch in the mouth which can be fluttered to increase evaporation and decrease their body temperatures by as much as 20 degrees Celsius. E. Endotherms generate heat by increasing muscle activity by releasing hormones into their blood streams or by producing heat in brown fat tissues. F. Panting, sweating, and spreading salvia or urine on their bodies are all options for the evaporative cooling of animals in hot environmental conditions. Answer. E. C. F summarizes the passage. Choice A is a minor point that supports major point C. Choice B is true, but it is not mentioned in the passage. Choice D is a minor point that supports major point F.